Welcome back to Topic 6 for Algebra 2, Relations and Functions. In Part 4, we're going to focus specifically on arithmetic combinations of functions. So here are the 4 arithmetic combinations of functions. We have a sum, difference, product, and quotient. We're going to use those 4 combinations in order to solve some examples. In our first example here, we have f plus g of x. So we have our function f of x equals 2x minus 3, and we have g of x equals x squared minus 1. So with this first problem, we're asked to add them. So this is the same thing as adding f of x plus g of x. So we can add our 2 polynomials together. This would give us 2x minus 3 plus x squared minus 1. Now we can combine our like terms and write our answer in standard form, so with the highest degree first in writing in decreasing order. We would have x squared plus 2x minus 3 minus 1. Combine our like terms and get x squared plus 2x minus 4. And again, this is what is called standard form. When we have f minus g, this is the same thing as f of x minus g of x. So we're going to subtract our 2 functions here. This will give us 2x minus 3, and then subtract x squared minus 1. Now here, I want you to think about the distributive property. This is really a -1 that we're going to multiply into each individual term here. Simplifying that, we'll get 2x minus 3 minus x squared plus 1. Now we can write our final answer in standard form, which gives us negative x squared plus 2x minus 2. In part C, now we're asked to multiply. So f times g of x is the same thing as f of x times g of x. Multiplying these, we have 2x minus 3 times x squared minus 1. So here I'm going to use the horizontal method, sometimes people refer to it as FOIL, in order to multiply these 2 polynomials together, or these 2 functions. 2x times x squared gives me 2x cubed. 2x times -1 gives me negative 2x, I apologize. Negative 3 times x squared gives me negative 3x squared. And negative 3 times -1 gives me positive 3. Now we can write it in standard form in decreasing order. So we have 2x cubed minus 3x squared minus 2x plus 3. Last but not least, we have division here. So this is the same thing as f of x divided by g of x, of course, where g of x cannot equal 0 because we never want to divide by 0 or have that in our denominator. If we were to set this up, we would get 2x minus 3 over x squared minus 1. Now in order to see if we can simplify, we can actually factor our denominator here. So our numerator would stay as 2x minus 3, but our denominator we can actually factor to be x plus 1 and x minus 1. This is because x squared minus 1 is actually called a difference of squares. This is a shortcut that we will review later as we move into our quadratics unit. In order to double check our work, we can multiply out our denominator and it will give us still x squared minus 1. Now, unfortunately with this problem, we cannot simplify anything in the numerator and reduce it with anything in the denominator. So we could actually write our final answer as this. Either would be acceptable though. Moving on to number 2, we have 2 new functions here. f of x equals x squared minus 1, and g of x equals x plus 4. Now, for part A, we have f plus g of 2. So this 2 is right where our x used to be. So instead of writing x, now we're going to plug in 2. So this is also known as when x equals 2. If we want to add our two functions together, we would have 2 squared, because again we're plugging in 2 for x, minus 1 plus 2 plus 4 for f plus g of x, or f plus g of 2 in this case. Now we can simplify. 2 squared gives us 4, and 2 plus 4 gives us 6. 4 minus 1 is 3. 3 plus 6 is 9. Moving on to part B, here we have f minus g of negative 3. So we're going to still use our function f of x, but wherever we see an x, we're going to plug in a negative 3. So we have negative 3 squared minus 1 and then we're going to subtract our negative 3 plus 4. So I like to reduce first and then subtract. Instead of distributing that negative, you're more than welcome to also distribute that negative though first, but I'm going to simplify using PEMDAS. Oops. Negative 3 squared gives us positive 9, and then minus 1. Negative 3 plus 4 gives us positive 1. 9 minus 1 gives us 8, and 8 minus 1 equals 7. Moving on to problem C, f times g of 0. So here we're going to multiply. We have 0 squared minus 1 times 0 plus 4. So of course we could multiply, but I'm going to first reduce in my parentheses. 0 squared gives me 0 minus 1, and 0 plus 4 gives me 4. 0 minus 1 is negative 1, and negative 1 times 4 equals negative 4. For part D, we have f divided by g of 7. So instead of x, we're going to plug in 7 for x. 7 squared minus 1 over 7 plus 4. 7 squared gives me 49 minus 1. 7 plus 4 gives me 11. 49 minus 1 equals 48. So we have 48 elevenths. If you would like to write it in, as this is an improper fraction, as a mixed number, this is equivalent to 4 and 8 elevenths. Not 8 elevenths, 4 elevenths, goodness. Okay, moving on, we could also write it in decimal form, if you would like to do that, as 4 and 364 thousandths, rounded to the nearest thousandths. Last but not least, we have part E, f times g of 0 plus f of 6. So we're going to plug in. F times g of 0 is 0 squared minus 1 times 0 plus 4. We actually already solved this earlier. But then we're going to add f of 6, which is 6 squared minus 1. 0 squared minus 1 gives me negative 1. 0 plus 4 is 4. 6 squared is 36, so we have 36 minus 1. Negative 1 times 4 is negative 4, and 36 minus 1 is 35. So negative 4 plus 35 equals positive 31. Thank you for watching Topic 6 for Algebra 2 on relations and functions, specifically arithmetic combinations of functions. Thank you for watching.